Hey trick class, this is your Notes on 9.3, the law of cosines now. So in the law of cosines, we're looking at other ways that we can solve oblique triangles, and that's SAS triangles and then side-side-side triangles. So we already saw the first two cases that we used to solve for the law of sines. Technically, it was, case 1 had two little subcases. But now case 3 and 4 is when we know two sides and the angle included, which is a little different than the ambiguous case of law of sines, the SSA case. And now we have three side lengths, known as the other possibility for the law of cosines. So you need to get down here that if you have these cases, it's the law of cosines. And if you have the cases that we saw in the previous video for 9.2, that those are the law of sines that we needed to solve those cases. Now, if you just saw this and there was nothing else there, that is the Pythagorean theorem, right? That just looks like the Pythagorean theorem. But the Pythagorean theorem happens when we got our three angles, right? And our opposite sides are A, little b, little c. And if this angle happens to be, this cosine, if this happens to be 90 degrees, then we get the side opposite that, c squared equals a squared plus b squared. What's the cosine of 90 degrees? It's the x-coordinate on the unit circle when I've rotated to 90 degrees, which is 0. And the x-coordinate there is 0. So this part would just go away, and it is Pythagorean theorem. So Pythagorean theorem is just one case of a bigger way to relate triangles, all triangles, and that is the law of cosines. So it is the Pythagorean theorem with this little piece attached. All right, now the reason why we see three of them here, they're all the same, but basically what it's saying, I keep drawing a right triangle, it doesn't have to be a right triangle. It could be something like that. There's A, there's B, there's C, little a, little b, little c. But what it's saying is, if I know, remember it was SAS or SSS, this is when we're going to use this. If I know side A, and I know side B, and I know angle C, that's SAS, that's this case, then I can solve for this side opposite that angle. So notice it's capital C, lowercase c over here, using little a, little b, and big angle C, right? But, what if I know little c and little a and the angle between those two, which would be angle B? But then I would use this one to find the side opposite angle B. So it's just giving me all three possible angles that I could possibly know in that SAS case. So that's why we're seeing three here. It's not like we have three different scenarios we're going to use it for. It's all the SAS case when we're solving for these side lengths. But we could also know all three side lengths. So I can know A, B, and C. And if I know A, B, and C, then I know this B and C. And then the only thing I wouldn't know there is A. And I could solve for the unknown angle. So, or the first unknown angle. So there is a use other than finding that opposite side length, and that's the SSS case. So that's the two times that we're going to use the law of cosines. So as soon as we've used the law of cosines, we're done with it. We're not going to use it a second time. Once we have used it the first time, we will always have an angle and its opposite side pair, and now we can go to the law of sines to find remaining sides. So the law of cosines is never really used more than once per oblique triangle, where the law of sines may be used multiple times. All right, let's start off with the SAS scenario. So notice here, I'm told this is angle B, that's capital letter, so this is little b, that's the 5. This is 50 degrees, that's the C, that's opposite the side C. And then angle A is here, so that's little a, that's the 4. So this is side, angle, side, SAS. So this is going to be the law of cosines. So the way that we're going to start off, we can't figure out what either of these angles are. And we notice we don't have a pair of an angle and its opposite side, angle and its opposite side. We don't have any of those that we can use the law of sines. So we have to start off with the law of cosines and find angle C. That's the only way that we can start here. So we set up this, plug everything in. A is equal to 4, B is equal to 5, negative 2 times 4 times 5, and then the cosine of 50 degrees. Make sure you're in degree mode on your calculator when you're using this if they've given you degrees, which they typically will for solving these triangles. All right, so doing the math, just keep in mind when you do all this stuff, this is c squared. So you are going to need to take the square root of that. You can go ahead and set it up like that if you want to. Like c is equal to the square root of all that stuff. But typically you'll round these to 1 or 2 decimal places for the side lengths, and usually a whole number for the degrees, maybe a tenth at the most. All right, so there is our first side length. Now, once we have an angle and its opposite, so we have angle C, which was given to us, and we have side length C from the law of cosines, now I can solve for angles A and B via the law of sines. Now, when I switch to the law of sines here, I'm always going to go to the angle opposite the smaller of these two remaining sides, because that one is guaranteed to be acute. There can only be one obtuse angle, right, in a triangle. There can't be more than one. So go to the smaller of the two, because you know that one has to be acute. Don't go to the bigger one, because when we're using the law of sines, sines can bring in ambiguity. Cosines won't, but the law of sines can bring in ambiguity. So I would set up the sine of angle A 4 as sine of 50 is to 3.91. So that means the sine of A is 4 divided by 3.91 times the sine of 50. So now I use inverse sine to solve for A. So I get A is approximately 51.6 degrees. All right, and since this is 50 and this is 51.6, I can find B with the 180 rule. The B is approximately 78.4 degrees. All right, so again, think of the process. How did I go through it? I found C, law of cosines, L-O-C, law of cosines. Then I found A, the law of sines, L-O-S, and then I found B with the 180 rule. So that's the procedure when I have an SAS triangle. Law of cosines, law of sines, 180 rule. Now, if you go through and look at the PowerPoint, they actually use the law of cosines on the two remaining angles, which, as you'll see here, this is their work to find angle A, 51.6. The same thing we got when we did the law of sines to find it, but it was significantly less work to find it with the law of sines. Right? We just did this, multiplied this 4 over, and got that inverse sine, and we got that. And again, there's all the work they did. I would think you would see that the law of sines is an easier path to get that angle than all that multiplication and work to get the angle A isolated from the law of cosines. But for sure, maybe if you find yourself liking that way better, use the law of cosines for both those two angles, but definitely don't use it for the third one, because all you have to do is the 180 rule. All right, so I don't understand why our PowerPoints are showing us to use the law of cosines for all three unknown values. So we get SAS, I would say law of cosines for sure to get that opposite side length, but then switch to law of sines, and then definitely the 180 rule on the last one. All right, so, side. When we have a side, again, same procedure. We want to do the law of cosines, then the law of sines, then the 180 rule, because we don't know any angles this time. So we're going to start off with an angle, but it's very important that we understand when we set this up, we never, ever start with the smallest or the medium one. We want to start always with the largest side length. Okay? And the reason is because if there is an obtuse angle, it's going to be opposite the largest side. And the reason we want to get that out of the way up front is because when we use the law of cosines to solve for an angle, we use inverse cosine. And if you recall, on the unit circle, the inverse cosine is quadrants 1 and 2, and it can determine if you have angles bigger than 90 degrees. It can find obtuse angles. Law of sines has inverse sine to find the angles. And that's only quadrants 1 if it's positive and 4 if it's negative. But they're always acute. The law of sines, if you use inverse sine, cannot find an obtuse angle. where the law of cosines can't. So that's why we always want to start with that first angle we solve for in the SSS case is always the angle opposite the largest side length. So c squared equals a squared plus b squared minus 2ab cosine of angle C. So subtracting the 25 and the 16 over, I get 8 equals negative 40 cosine C. So cosine C equals, if I divide, I get 8 over negative 40. That's going to reduce to negative 1/5. All right, and cosine C equals that, so C equals the inverse cosine, which is about 101.5 degrees. So there is my first angle. That's my obtuse angle. Okay, I'm setting that up because, again, 7 is the largest. Obtuse angle would have to be opposite the largest, and it was an obtuse angle. Right now I have an angle that's opposite pair. So to solve for either of the remaining angles, which could be acute, doesn't really matter. I'm going to do the smallest one, so I'm going to do B. So I'm going to say the sine of is to 4 as the sine of 101.5 degrees is to 7. All right, so sine of B equals, again, move the 4, multiply both sides by 4, so I'd have 4/7 the sine of 101.5 degrees. So B is the inverse sine of all that. So B is approximately 34.1 degrees. And then the 180 rule to find angle A. So angle A is equal to, we start with 180, subtract what we got for C, subtract what we got for B, and we get A is about 44 point. So remember, side, 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 I will need to find all 3 angles, and there are my 3 angles. All right, and now this is an application of the law of cosines. So again, we have to come up with an SAS or an SSS scenario for this. So what we're doing here is we're traveling by boat from Naples to Key West, 150 miles. We've gone 15 miles an hour for 4 hours, so that means we've gone 60 miles, and we're off by 20 degrees. All right, so how far is the sailboat from Key West? What angle should we correct it, and how much time has been added to the trip because of this, assuming we maintain that 15 miles per hour. So let's look at the first question. So this is, again, the trajectory we wanted to be on, but we got off by this 20 degree angle right here, and we've gone 60 miles in that direction. All right, so for the next question is how much further do we have? Well, if you can see here, we know how far the distance is. That's 150, that's this one. And we know we've gone 60 because we've gone 15 miles an hour for 4 hours, and that's 20, and we need to find this. So this is an SAS. All right, this is the 20 degrees in the middle, this is the 60 miles, and this is the 150 miles. So that's SAS, and notice this X, nice thing about it, it's opposite that 20. So that's the thing that we need to set up to solve. So X squared is equal to 60 squared plus 150 squared minus 2 times 60 times 150 times the cosine of that 20 degrees. All right, so there's our setup. All right, doing a little bit of math, we can see that, again, take the square root of all this. You can actually put all of that into a calculator as long as you're in degree mode, and it would tell you that approximation there. So take the square root of that 9185.53. You get about 95 miles left to go. All right, and the next thing we want to find is this correction angle. And with this picture, we can see that this angle plus the angle that we need to correct by. Okay, we need to go this many degrees in the opposite direction. Those 2 angles will add up to 180. They form what we call a straight angle. So now that we know all 3 sides of this triangle right here, we can find this angle that's opposite the 150 and then subtract that from 180, and that will be my correction angle. So call that angle A. There's the setup. 150 is opposite that, and we found this to be about 95.8, so 96 is what we're using, rounding it to the whole, and there's our setup. So then we just do a little bit of work, inverse cosine to find A. So there's our angle that is within that triangle. The correction angle is going to be the 180 minus that. So about 32.8 degrees to correct us back onto the right course. All right, so as we saw, we've already gone 60 this way. We're going to have to go 96 roughly that way. So if we add those 2 together, That's now 156 miles total, where it was just 150 miles straight away. So we have added 6 miles, and 6 miles at 15 miles per hour is 0.4 hours, which is 24 minutes. That's all we've added onto the trip. So there's not a huge blunder here. Again, assuming that we maintain that 15 miles per hour.